Hello, this is Pete Catropi. I'm Chief Scientist at Appalachics, and this is video number 4 in the Gurobi Machine Learning webinar series of tutorial videos. In the previous 2 videos, we focused on machine learning tasks. We used cross-fold validation to select the appropriate algorithm for our historical data, and then we created a predictor object from that historical data table and turned that predictor object into an application capable of making predictions. Now we're going to focus on the optimization part of pipelining machine learning and optimization together. So here, as you can see, I've opened up the sort of promotion example in the ticdat repository. If you refer to video number 1 in this series, I walk you through the steps of downloading the ticdat repository and creating the files necessary to run these examples. So let's look at this file, soda-promotion-optimizer.py. This is a Python script that imports Gurobi and ticdat. It uses Gurobi as its mixed integer programming engine, and it uses ticdat to handle data I/O and to give it a command line interface. So the first thing it does with ticdat is it defines the input schema, and then it defines the output schema. So this just means it defines the tables and the fields that it's going to be reading from and writing to. Next is a solve function. I'm not going to dig into details here. If you refer to the video, to the webinar itself, you can see how Daniel walks you through the precise details of how the solving is performed. Now, if I scroll down to the bottom, these 2 lines of code redirect the command line arguments to the standard main function defined by ticdat. Ticdat can then parse the command line arguments for you, and since you pass along to the standard main function the solve function, then the standard main function will call the solve engine with the appropriately read data and will write the data back for you. So let's see how that works in action. Here I'm in my local copy of the soda promotion example. So you can see here's the soda promotion optimizer file that we're going to run. This is the Python script that we're going to run. And you can see that here is an Excel file that was created in video 1 when I created the Excel files from the human readable files. So this file here, optimizer only test input. Let's open that up. Let's see what's in there. So it's an Excel file. I'm running OpenOffice here on this computer, but obviously you can open it with Excel or any Excel-compatible file editor. You can see it has the tables that we need that you're expecting. It shows what the max number of promotions is for the soda types. It has a parameter table, which defines the maximum total investment. It has a products table, which tells you which family type you're using for each type of soda. And then it has a forecast sales table. Now, of course, this forecast sales table has the dependent column populated, and it only has the independent columns that are directly relevant to optimization. So in other words, we're assuming here that the machine learning task of populating the dependent column has already been performed. Now, for development purposes, it doesn't really matter whether a testing set like this is making particularly good predictions or not. This is the file, optimizer only test input.xls, is a file that you would build as a developer just to exercise your optimization engine in isolation. Because you want to make sure that your predictor engine and your optimization engine are both working properly before you try to connect them together to make one big application. Now to see if it's working correctly, let's run it. Oops, optimized. We're supposed to be running on soda promotion optimizer.py. We're going to tell it as an input. And its output is going to be, oops. We're going to tell it to create a file solution.xls when it solves. So what's happening here is that Python will be running the soda promotion optimizer script, and the ticdat library will be parsing our 2 arguments, and it reads from optimizer only test input.xls. It creates a data object that the solve function can process, and then solve function returns the solution data object, which ticdat then writes to the output argument of solution.xlsx. So let's open up the solution file that was created. And this has some values, these tables that you would expect. It has a parameters table that shows the total KPIs, and it has a product pricing table that shows the product and the for each product, for each price, and it tells you which product family that product belongs to, and then it tells you the promotional status of that price. So this is all well and good. So for development purposes, you can develop a file like the soda promotion optimizer.py independently of your production environment. So now that we have this file working properly, let's load it up onto our production platform and turn it into an application. So here I'm on the Athletics Cloud platform. These are the two projects, the two machine learning projects that I worked on in the previous two videos. Here we're going to create an instant app. So this is a review. This is the machine learning app that we created in video 3. Here in video 4, we're going to create an optimization app. So we're just going to call this Optimize Soda Prices. And we're going to load it up with the file that this same soda promotion optimizer.file. We're going to load it up into our platform. And let's save it. And it says that an application has been created. So let's validate that. We go back to our projects. These are the soda promotion. Now let's upload a file. And again, we're going to upload the test input file. And as the solve type, it's going to be this custom application that we just created, the optimized soda prices application. Let's see if it loads up correctly into there. And it loads up. Just to review what the data looks like. Here again is the same data. It's nicely easier to work with here inside a Slick GUI than it is in an Excel file. So now let's run the optimization engine. And it ran successfully. So if you look at the KPIs, these KPIs are the same as these KPIs, right? Yep, they're exactly the same. And here we have the reports as to which, as to the prices for each soda. And again, just with a quick glance, the data looks exactly the same. Of course, we can filter it here, or we can sort it here and see. Okay, we have 2 discounts for clear soda and 2 discounts for dark soda, as we would expect. Okay, so this concludes the optimization piece of the Gurobi webinar series. And there's one more video where we put the optimization engine and the predictor engine together to create one big application that will first predict and then optimize. So I hope you join me for that video, and thanks for your attention.